Hi, Claire.
You're way more.
Hi, Claire.
You're way more funner than the 5th period class. This is 8th period, Claire. So we've got the fun group now. 1-7. We just got done solving like systems and doing 2 equations at the same time, which is slightly difficult. Substitution and elimination, slightly difficult. This is a little bit easier than that. This is graphing, but it's like decent graphing. It's not too hard, okay? There's that word again, inequality. Inequality, what does that mean?
There's no equal.
Not equal. If it's not equal, what is it?
Greater than, less than, equal to.
Greater than, less than, greater than or equal to, less than or equal to. We know how to graph these. If it is a greater than or a less than sign, you do a
triangle.
What?
Dotted line.
Dotted line. If it's greater than or equal to, less than or equal to, you do a
solid
line. And then we'll talk about shading, okay? We've graphed these individually before, but now we're doing 2 of them at once. So we're graphing 2 equations at once. This is a system of inequalities. So we'll talk about how that is a little bit different here in a second. So we're going to graph this guy, and this example 1 is very, very nice because he is ready to be graphed. He is ready to go. The y is solved for. So I treat this just like he's an equal sign, but then the shading is going to come into play later on. So I'm looking at the 2x minus 4, and I start at -4, and then I go
up 2 over 1.
Up 2 over 1, up 2 over 1, up 2 over 1, and I do that. Or down 2 to the left 1, okay? And is that supposed to be a dotted line or a solid line?
Dotted.
It is supposed to be dotted because it's just greater than, not equal to, right? So just a dotted line. I'm going to kind of dot him a little bit, okay? And this thing says greater than. If I look at this little symbol, greater than, so which way do you shade?
To the right.
Kind of to the left and up-ish,
Duh.
right? Left and up-ish, okay? That's my first guy. Okay, my second guy, I don't like the way that that is written because we never put slope as a decimal, right, Caden? I always get after you all the time. Never put slope as a decimal. So what does -0.5 actually look like?
1/2.
-1/2. So we're going to keep that in mind. All right, start at the +3. And I go down 1 over 2, down 1 over 2, down 1 over 2, or up 1 to the left 2. Put a few dots in there, and we're going to draw a line. Solid line or dotted line? This guy tells you it is solid. Yep, something like that. And we go to the
top. Yeah.
y is what?
Less than.
Which means we go to the
Bottom.
bottom, like bottom and left-ish. Okay? Now, here's the difference. When we were doing this before, we would just shade it and be done.
Yep.
But now we have kind of like 4 sections on our graph. When we have 2 lines that cross each other, it makes it into like 4 equal sections. Not equal, but 4 sections. Which one of those 4 sections is like double shaded?
That one.
Like quartile 2,
Like-
3.
Yeah, like like the 4th quartile or fourth quadrant, I guess. Third quadrant. That guy. So shade him really dark because he is only coordinates that live in that region are ones that satisfy both equations. So name me a coordinate that lives in that region.
0, 0.
-2.
0, 0, -4 what?
-6.
-4, -6, right here. Okay.
-2.
-2, 2. You betcha, that's there. Okay. Any of those? So we said 0, 0, -4, -6, -2, 2. Any of those dots? 1, 1, 1. Technically works, yes. What about 0, 2? No, excuse me, 2, 0. What about this guy right here? 2, 0.
No.
Does he work? Why does he not work?
Because he's just
On the line.
He's on the line and it's dotted, which means that it doesn't touch the line exactly. What about the point 0, 3?
Yes.
This guy. He is on a solid line, so he does work, okay? So only points that are in that region fit both equations. Now, you might have some that are in this region that fit one equation or some that are in this region that fit one equation but not both. So the solution is the region that's double shaded. Does that make sense? Okay? All right, so let's go to this next one. Solve the system of inequalities by graphing. Same thing again. Okay, except we're going to end up with some weird things. That's okay.
How weird.
Okay, starting with the top. I'm going to do this one in pink. So we start at the...
First off, these are
They're
parallel.
parallel.
They are parallel. How can you tell that they're parallel?
Because they have the same slope. slope.
The slope is the same, so both of them are 1s, all right? Okay, so we start at the 5, and we go up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1, blah, blah, blah. Keep doing that. Okay, and should this first one be solid or dotted?
Solid.
This guy tells me he is solid. Okay, draw my line. There's my first one. Okay, and oh, which way do I shade? Y is
Above.
greater than,
Up.
above. Above and to the leftish. Okay. All right, second one. I start at -4, and I go up 1 over 1, up 1 over 1. These two lines should be parallel. If they're not, you did something wrong. And he should look like that. Solid or dotted on the second one? Dotted on that one. Okay. And Y is less than him, which means we go to the bottom. Uh-oh.
No solution.
Uh-oh.
No solution. Comment.
So give me a point that is in the top shaded region and the bottom shaded region at the same time.
There's none.
There is none. So,
No solution.
like Kyle said, no solution. So you can either do a circle with a line through it, or you can say no solution. There is not one point that lives in both regions, so there is nothing that works for both of these equations. Okay, so you might end up with something weird like that. Okay?
Wait, what if?
What?
The door's right there. Take a hard 90 to the left and keep going.
I have a question. So, if they're parallel lines and they shade like both like towards each other, would that be?
I don't know.
What would that be?
Why don't you have a block?
If they shade towards each other,
Yeah.
like in the inside,
Yeah.
then that's fine. Then the solution is just that shaded region.
Yeah.
Yes,
Yeah.
correct. Okay, I'm going to add an example in here because sometimes they'll do this to you. Okay, let's say you have x is greater than 4. How do you graph x is greater than 4?
You have a line that goes on the
Okay.
X.
Think about x equals 4. Okay, if you're graphing x equals 4, you go to 4 on the x-axis, and then what does it look like?
It's a vertical line.
It's a vertical line straight up and down, except this one is
dotted.
dotted. This one is dotted. So I'm going to do a dotted line at 4. Okay.
So
Now
there's-
remember that x equals 4 is a vertical line, which is opposite of what kind of you sometimes think because the y-axis goes up and down, but x equals 4 actually goes straight up and down, okay? Y is less than or equal to -1. I'll do that one in green. So I go to -1 on the y, and he is a
Horizontal.
horizontal line, solid, right? Solid line, okay? Oh, shoot, I forgot to shade. Y is less than or equal to -1, so that's below, okay? Which one do I shade on the other one?
To the
X is greater than 4 to the right. So which region is double shaded?
Like
quadrant
far
four-ish.
quadrant 4.
Yep,
Right?
quadrant 4, the bottom right quadrant. He's double shaded. Does that make sense? So sometimes you'll have stuff that looks like that, where you'll have like just X and a number and Y and a number, and those are those horizontal vertical lines. Perfect. Okay, good.
Yeah.
All right. This is the nope, 2 left. 2 left. Example 3. Chelsea has final exams in calculus, physics, and history. She has up to 25 hours to study for the exams. They're going to give us lots of stuff going on here. So 25 hours max. I'm going to put that down. To study for the exams. She plans to study history for 2 hours. So we know right now that history equals 2 hours. If you look at the graph that they've given us, they don't even put history on the graph, right?
So there's 22 possible hours.
Yes, correct. So physics,
Oh, wow.
physics they're representing as which variable? Which one is physics? X or Y?
X.
Physics is the X.
I guessed
Calculus
that.
is the Y. How do we know?
Because it's up and down.
The line.
Duh, it's on
Right?
the y-axis.
Y-axis, X-axis. So use your little clues. They'll do that on your homework assignment. They'll call them something else, but then you identify them as X and Y, okay? So X is physics, Y is calculus. All right, so let's talk about X and Y. X plus Y together has to be what?
25.
Less than or equal to 25.
Less than or equal to
23.
20.
Lose.
technically 23, yes, because we're already doing history for 2 hours, right? Okay, you guys understand why that is? X and Y, the number of hours added together has to be less than or equal to 23, yeah? So that's our first, that's probably the hardest one that we have of all. She needs to spend at least 7 hours studying for calculus. Which one is calculus, X or Y? Y. So Y has to be at least 7. What does that mean about Y?
Y is
greater than or equal to 7.
Y is greater than or equal to 7. But 14 is too much. But over 14 hours is too much. So that means Y has to be less than or equal to 14. Okay, now we're going to talk about physics. She hopes to spend between 8 and 12 hours on physics. Okay? So X is greater than or equal to 8 and X is less than or equal to 12. Did you know that sometimes, you don't have to write this down if you don't want to, if this confuses you, sometimes they will combine these two together and say 8 is less than or equal to X, which is less than or equal to 12. They'll write it like that.
Yep.
That's a way of writing them all at the same time. Okay, Y's, you could do those together as well, and you could say 7 is less than or equal to Y, which is less than or equal to 14. Right? Have you seen that happen before?
Yes.
Okay. All right, so if you see that, don't let it confuse you. If you want to write them as two separate pieces, you sure can. They want us to write and graph a system of inequalities to represent the situation. Here is that. Holy Toledo, that's a lot of stuff that we've got going on. Okay? Yeah? Yeah. All right, so let's start with the easy ones. We'll save this guy for last. Okay, so let's start graphing. I'm gonna do the Y's first. Okay, so Y is greater than or equal to 7 and Y is less than or equal to 14. So if we're graphing Y is greater than or equal to 7, what does that look like?
What?
Y is greater than or equal to 7 if we want to graph that guy.
Y. Well, you're gonna have
A horizontal line at 7.
1, 2, 3, 4, 5, 6, 7. I'm gonna do a horizontal line at 7. It should be solid or dotted? Solid. Okay. There's my solid line at 7. Okay, and then let's also do 14. So Y is less than or equal to 14 means 7, 8, 9, 10, 11, 12, 13, 14 right there. And he is another solid horizontal line. And I have to study between those two numbers of hours. So lightly shade in between those two rows there. Okay. All right, same thing. Now let's do physics. This is physics. So my X's have to be between 8 and 12. So let's do a vertical line on 8 and a vertical line at 12. Yeah?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, something like that. 8 and 1, 9, 10, 11, 12. 8 and 12. Oh boy, I'm really terrible at these lines here. There we go. Okay, and it has to be between those two. Okay, so now we have a region. You see that little rectangular region that is doubly shaded in the middle there? Yes, okay. But we're not done graphing. We have one more thing that we have to graph, and I'm going to do this one in orange. And that is this guy right here. But I am not ready to graph him yet. X plus Y is less than or equal to 23. What do we need to do before we graph?
Plug something in for the Y.
Not necessarily.
No, you gotta put the Y by itself.
Yeah, we gotta get the Y by itself. So how do I move that X? Minus X. So Y is less than or equal to, how do we want to write it?
23.
Nah.
X plus 23.
Nah.
Negative X.
Negative X plus
You know what?
23.
I don't really care. It's gonna.
That's what we're gonna start with. That's what we're gonna start with. I should go through and label these guys. I should go through and label. This guy was 7, this guy was 14, this guy's 8, and this guy's 12. Okay, so I'm gonna do that. Alright. So alright, so we want to go up to 23. We want to start at 23. I know that my top line here is already at 14, right? So I'm just gonna go 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, like right below the R on graph. Right below the R on the word graph.
I don't care.
That's 23.
They didn't give us enough space. It's going right below the arrow.
Okay, sure. Right below the arrow?
Yes, ma'am.
Oh my gosh, your graph's gonna be off.
I don't really care.
Okay. So,
If they
there's
did-
that. Now, question to you. Rather than going down one over one, down one over one, down one over one, down one over one, if I keep going down one, I'm at 23 here. If I keep going down one over one, down one over one, down one over one, where is he going to intersect over here?
23 on the other side.
23 on the other side. Do you agree?
Yes.
So sometimes it's a better strategy to find that spot over here. 23 on the other side is about there. Okay, because it's the same spot, like same spot above the arrow or to the right of the arrow. And I'm going to do that, and then I'm going to take a piece of paper, because I can't draw straight lines to save my life. And I'm going to do one of these. There we go. That was really good.
I got this.
Boom.
Just drew a draw line.
Just draw a straight line. Now, y has to be, oh shoot, that was a solid line. I did that right?
Yes.
It has to be what?
Backwards.
Less than.
Ooh.
Less than, which means
Hello.
below. So which region is like quintuply shaded?
What? It's 3 times.
The region that's quintuply shaded?
Blue one.
Well, it's really just 3 times
It's right
shaded.
here.
Yep. Right here, this region.
Really don't like this.
Okay.
Well, we
So
don't really like
we've
you either,
taken the rectangle and we've lumped off the corner of it.
You know, Kyle, nobody likes you, but we don't ever say it out loud.
but you know what? Caden and I are buds, especially in ag class, because I give him like 90% of the answers. There you go, Claire. Now you have some beef on us. I give Caden answers.
Okay.
I helped Hayden on his math homework.
So we had a rectangle before, but now we've lumped the corner off, which means anything that was in this range right here is no longer acceptable. We cannot have 12 hours of physics and 14 hours of calculus. This would be the point 12, comma 14.
Could.
Because why not?
It's 26 hours.
That's 26 hours and we only have 23 hours to devote,
Yeah.
right? Okay, so we can pick anything that is in that region. Okay,
Okay,
write and graph a
I-
system of inequalities to represent the situation. So let's pick like 2 points that lives in there.
9.
9, 9. I heard
Yeah, sure.
Luke say 9, comma 9 would work. That's 18 hours. That's less than 23. The slackers, what are they gonna do?
Let's do
Probably
10.
8, 7.
Probably 8, 7, right? These are the slackers. They're gonna do as little as possible. 8, comma 7. Okay. The overachievers, what are they gonna do?
Like
the max.
14.
We're gonna do like
They're gonna do 14, comma. No, wrong.
No.
What, comma 14?
14,
It's like,
comma, 9.
2. So
14,
9.
comma 9. But yeah,
9, comma
10.
14.
He's like
Yeah, whatever.
Right? 9, comma 14. Or they're gonna do like 12, comma
11.
11, right?
Anything on that line.
Anything on that line is going to be the overachievers because they're going to use all of their resources to the max, all 23 hours, right? Yeah? Okay? All right, good? Makes sense? Yeah, okay, now, last one. Example 4. Here we go. Find the coordinates of the vertices. Let's talk about vertices of a triangle. Here's what a triangle looks like. If you didn't know the shape, that's what it is. That's a triangle. What are vertices of a triangle?
The point, the end.
This guy and this guy and this guy. That's what we're trying to find. It looks like a Christmas tree now. Ha! Look at that. Look
You
at
should
that.
add a little brown. and
Okay,
put it like
so-
the stump.
We have 3 equations given for the 3 lines. So we're starting with y is greater than or equal to, I'm just rewriting these, 2x minus 8. Okay, the second one, y is less than or equal to negative 1/4 x plus 6. And 4y is greater than or equal to negative 15x minus 32. Okay? All right, are all of those ready to be graphed?
No.
Which one's not?
The last one.
The last one. This one is not ready to be graphed, so let's fix him. How do we fix him?
By 4.
Divide everything by 4. Divide by 4, divide by 4, divide by 4, and don't make it a fraction. Or don't make it a decimal, I mean. Negative 15 divided by 4, just leave it. It's going to be kind of ugly, but that's okay. Negative 15 over 4x minus 8. Okay, so there's that one. I'm going to graph these in different colors, so we'll go maybe purple. And we'll go with blue.
You're so lucky you can use colors.
I know, isn't that awesome?
I'm using colors.
I mean, I could. I just don't.
Purple, blue, and pink. Okay, let's do the purple one first. Let's do the top one first.
Purple. That's my
Where do you
purple
start?
one.
Negative 8, you betcha. And then we go. Start at negative 8, and then we go.
2 over 1.
Up 2 over 1, up 2 over 1, up 2 over 1. Okay, solid line or dotted?
Solid.
all of these are solid, right?
Yeah.
Yeah.
Yeah, all of them are solid. Okay, so there's that guy. And we are going to shade.
Uh-oh.
You're gonna shade it, so that way it's going to the left.
To the left and up-ish, right? And I'm just going to cheat and I'm going to do this. I'm going to make some arrows here so I don't mess my paper all up. I'm going to do that. Can you see that? They look like little mushrooms growing off of my line there, but whatever.
I like mushrooms.
Okay, blue line, middle line, start at 6. And we go down 1 over 4, down 1 over 4, uh-oh. Up 1, left 4, up 1, left 4. He has a solid line also. But he's kind of yucky because he doesn't cross very nice over there. We got to find where he crosses. Less than, shade. Down. I'm going to do my little arrows again.
Oh, my mushrooms are ugly.
Okay, last one. Pink one.
Literally jump up 15, go over 4.
We go 8.
You didn't make
I erased.
Why does it go down to up?
Go down 8. Now, from the negative 8, I want to go down 15 and over 4. And Sarah's like, I can't go down. Because I'm already almost off the chart.
Well, no, I
So what do you do instead?
You
Go up,
15,
but-
Up
Backwards.
15 and to the left 4. Okay, now, before we start counting, hold on. We're down at negative 8, and we want to go up 15. If we're at negative 8 and we want to go up 15, where will we be at?
7.
7.
I don't know.
Like negative 8 plus 15 will be 7, or 15 minus 8. We'll be up at 7, and then we go over 4. Oh, man.
Oh, yeah.
Oh, yeah. He's crossing right there. Perfect. And I'm going to use my paper to draw a line here. Is that my
Oh no.
paper's still
There's
moving?
a hill in my line.
I can't draw lines very
Oh
good.
no,
There we
my
go. There we go.
mushroom.
There we go.
You're just sneaking in.
All right, and he is shaded to the greater than.
To the greater.
To the greater than, which means he is
That way.
a triangle. Yeah?
He is a triangle.
He's all shaded inside the triangle. Okay? Now, what was our goal?
What?
What was the goal here?
Find the middle. Alright.
Find the
Vertices.
vertices. Find the vertices. So, this guy right here, that coordinate, what is that coordinate? The bottom one.
Negative
8.
0, negative 8. 0, negative 8. That's where he's at. Okay? Other ones. Where else is he crossing real nice?
Backwards.
Over here?
Oh.
Where is that point?
Well, like 7. 7, negative 4.
Negative 4, 7.
Negative 4, 7.
There you go.
Nobody's known.
Negative 4, 7. Those two. Okay, now, what about this guy?
I don't like that one.
That's
6.
I don't like that one either. We don't really know where he crosses at.
It's 6.
I could take a stab, but I don't know if that's exactly where they cross. It kind of looks like maybe 6, comma 4.
No, it's like 3. It's like 3.
That is.
I don't know where he crosses. So if I'm looking to find,
5-3, isn't it?
no. If I'm looking to find where two lines cross each other, what could I do to find where two lines cross each other?
I don't
Use
know.
the equation.
Use substitution or elimination, right? Oh, man.
Is Kyle Hubble in there?
He is.
Could he come to the office for a minute, please?
Sure.
Ooh, what did Kyle do?
So,
I was hoping he'd be leaving.
on that last vertex, we're trying to find where those two lines cross each other, yeah? Okay? Which is the purple and the blue line if you're color-coded like I am, which is those first two equations, right? I want to figure out where those two lines are crossing each other. So we just learned how to find where lines are crossing. We do substitution or elimination. So I'm going to start with, and I'm going to get rid of the inequality symbols. We're just going to treat it as though it says y equals 2x minus 8 and y equals negative 1/4 x plus 6, because I'm trying to figure out where they're equal to each other, where they're crossing each other, okay? So don't worry about the inequality symbol now. We are trying to find where they cross. What do you want to do? Do you want to substitute or do you want to eliminate? I am wanting to
I don't
substitute.
even remember what those are.
I want to substitute because the y is solved for. I've got this y is equal to 2x minus 8. So what I can do is I can take that 2x minus 8 and I can go whoop right in there.
Oh.
Right?
No,
I'm not dumb.
because it's an inequality.
But we're trying to find where they're equal to each other, where they intersect. Does that make sense?
Yep.
So I changed them to equal now. Okay? So I'm lumping that 2x minus 8 into that y, and now I have no y's anymore. Does that make sense? This guy took the place of the y right there. And now I'm going to solve. How many pieces are up there?
4.
4. 1, 2, 3, 4. These are my x's. Get them together first.
What?
What?
Equals
Nothing.
1.2.
Okay,
9
so
over 4.
Dying.
So let's move the 1/4 over. So let's add 1/4 x and add 1/4. Okay, so this is 2 and 1/4, right? 2 plus a fourth. We're going to change that to an improper fraction here in just a second, like what Luke just said. But we'll leave it as 2 and a fourth x minus 8 equals 6. Yeah?
Plus
Okay, let's add the 8 over.
equals 14.
So 2 and 1/4 x equals 14. Okay, now what is 2 and a fourth as an improper fraction? Do you remember how to do this?
4.
You take 4 times 2, and then you add the 1.
Yeah.
So you said 9 over 4 equals 14. Okay, now how do I get rid of the 9 over 4?
Multiply it by 4.
Divide.
You divide by 9 over 4, which is the same thing as multiplying by the reciprocal. So I'm going to times by 4 over 9. So cross that off. Times by 4 over 9. This is like 14 over 1 times 4 over 9. Now at this point when you're multiplying, we want to try to reduce if we can. So will anything cross out?
Will 1 and a 4 cross out?
No,
Oh, you
because
can't have a 0 on the bottom.
Right,
Oh,
right.
I knew that.
So 14 and 9, will those reduce?
No.
No. Let's go ahead and do
Oh, that's ugly.
14 times 4 over 9. 14 times 4 is 56.
Yeah.
So this is 56 over 9. Ew, gross. Ugh. Let's go ahead and do a decimal. 9 times 6 is 54, so this is 6. 54, that would be 2 left over, so this is 6 and 2/9. Do you know what 6 and 2/9 is as a decimal? Do you know what your ninths are?
Nope.
You ready? This is very easy.
Not my ninths.
1/9 is 0.1 repeating. 2/9 is 0.2 repeating. 3/9, which is 1/3, is 0.3 repeating. 4/9 is, you guessed it,
no way.
0.4
No way.
repeating.
No way.
No way. No way. 5/9 is 0.5 repeating. 6/9, which is 2/3, is 0.6 repeating. Do I need to keep going?
No, I can.
What is-
think so.
What is 9/9?
100. Wait.
1.
I was waiting for somebody to say 0.9 repeating. It is 1. That's the only exception to the rule, right? Haha, Cody missed it.
How many
Kyle missed it.
dimensions do you have?
So,
Kyle is qualified from cross country.
so
Good,
X is 6.2 repeating, or we'll just say 6.2 if we round. X is 6.2
Or we could do the fun one where you just write it on the until you run out.
till you run out of room.
Yeah.
6.2. Would you have guessed that the coordinates of this guy is 6.2 comma something? Nah, probably not. Now we're not done yet. We gotta solve for y. Which one would you like to plug into? The first one, definitely for sure. I don't like fourths. Okay, don't use a calculator. What's 2 times 6.2 in your head?
12.4.
You betcha. 12.4, and let's subtract 8. 4.4. Do this stuff without a calculator. You can do it. You just proved it to me. Okay, so what were we trying to find? That was a long problem.
13.
We were trying to find the
Red and
vertices. So we found them. They are, if you want to write them again, -4, 7 and 0, -8. Those were the nice ones. And then the other ones were 6.2, 4.4. Those are my 3 vertices. Good? Yes? Okay. So I have a homework assignment for you, and it looks something like this. This is practice, and skills practice is this guy, whatever, okay? So
May or may not cry, it's fine.
I'll tell you which ones I want you to do. Claire, I think I have these written down on a page for you already.
Oh yeah, I forgot.
Everybody say bye, Claire.
Bye, Claire.
Adios.
Hasta la vista.